Orbital data centers gain ground in the AI race. As artificial intelligence workloads surge, the limits of terrestrial infrastructure are becoming harder to ignore. Atomic Six's ODC.space platform reframes orbital data centers as a practical extension of digital infrastructure rather than a distant concept, introducing a marketplace model for accessing compute capacity in orbit. A marketplace approach to orbital compute, ODC.space signals a shift in how organizations could approach large-scale compute deployment. Instead of building dedicated satellite systems, users can access orbital capacity through a marketplace interface that allows them to define pricing, timelines, and technical requirements in one place. The model echoes the rise of cloud computing, where infrastructure moved from capital-intensive builds to on-demand services. By abstracting much of the complexity tied to space systems, Atomic Six is positioning orbital compute as an option not just for aerospace specialists, but also for AI firms, software providers, and public sector users. Speed is a key part of the pitch. While traditional data centers can take more than 5 years to permit and construct, orbital systems are expected to come online within a 2 to 3 year window. For organizations facing immediate capacity constraints, that shorter timeline could carry weight. Earth's limits, space as an alternative. The case for orbital infrastructure is tied closely to growing friction on the ground. Data center expansion is increasingly shaped by land constraints, grid limitations, and regulatory delays. As AI models demand more power and compute density, those bottlenecks are becoming more visible. Shifting workloads into orbit introduces a different set of conditions. Space-based systems avoid many of the environmental and permitting challenges tied to terrestrial builds, while drawing on solar energy and alternative cooling approaches rather than water-intensive systems. That said, orbital data centers are not being positioned as a blanket replacement. The model is more likely to serve specific use cases, including workloads requiring secure environments, global reach, or proximity to data generated in space. In those scenarios, physical separation and reduced interference risks may offer tangible benefits. Engineering for a harsh environment. Deploying compute infrastructure in orbit still depends on solving persistent technical challenges. Atomic Six's approach focuses on power generation, thermal management, and system durability. The platform incorporates deployable solar arrays to provide continuous energy, alongside radiator systems designed to handle the heat generated by dense compute operations. Protective shielding is also part of the design, intended to reduce exposure to micrometeoroids and debris that could disrupt operations. Atomic Six is also packaging the offering as a managed service, covering spacecraft integration, launch logistics, licensing, and in-orbit operations. This end-to-end structure reinforces the company's framing of orbital compute as a usable infrastructure layer rather than an experimental deployment. As the space economy continues to evolve, orbital data centers are moving closer to practical consideration. Whether they can meaningfully offset terrestrial constraints is still an open question, but marketplace-based access suggests the conversation is shifting toward implementation rather than theory.